Hello students, welcome to Academy, the place for mathematics and science. Dear students, you all know that in the chapter magnetic effects of electric current, we were answering for the questions that are given in exercise. In yesterday's class, we finished answered for first 13 questions. Now let's go for continuing this. Now this is 14th one. Observe this. Two circular coils A and B are placed close to each other. If the current in the coil A is changed, will some current be induced in the coil B? If so, give reason. Hope that you have understood the statement. Look here. Let's go for writing answer. Before that, just I make you to understand the meaning of this whole statement. Here they have given two circular coils A and B. I'll go for drawing that. Observe it. This is the first circular coil. You may call it as A. And let me draw another circular coil. You may call it as B. Followed. Next, are placed close to each other. If the current in the coil A is changed, so therefore the free ends of coil A should be connected to terminals of a battery along with the switch. Let me show the switch here, and this is positive terminal and is negative terminal. If the current in the coil A is changed, will some current be induced in the coil B? So as we are going to check whether the current is induced, hence the free ends of the second coil B should be connected to terminals of a device which detects the current, that is galvanometer. Now, this is the figure related to the given statement. Let's go for answering. If there is change in the current of in the coil A, whether the current is induced in the coil B. I'll explain, then you decide. Look here. Here in the coil A, first I close the circuit. You all know that the current starts flowing from positive terminal to negative terminal of a battery. Right? Then according to the magnetic effects of electric current, whenever the current flows through the conductor, the magnetic field is developed around it. Right? So here the magnetic field is present. As the coil B is placed close to A, the magnetic field will also be here. That means coil B is in the magnetic field of coil A. Please do remember. If there is change in the if there is change of current in the coil A, that means I am going to change the current by, look here, by introducing one more cell. Then current is increased. Then obviously the magnetic field linking with this coil also get changed, right? Then as the coil B is in the magnetic field of coil A, the magnetic field linking with the coil B gets changed. As there is change in the magnetic field, current is induced in the coil B. Followed? Yes. Now, current is flowing in the coil B. Hope that you have understood. We have to write to answer that. What do you say? Will some current be induced in the coil B? Yes. Why it is so? Look here. The magnetic field which is linking with the coil B gets changed. How? When the current flows through the coil A, the magnetic field is developed around it. B is in the magnetic field of A. When the current is changed, magnetic field linking with the coil A also gets changed. As it surrounds B, this also gets changed. Hence, current is induced in coil B. Hope that you have understood. Now, I'll go for writing the answer later. Focus on 15th one. 15th one is state the rule to determine the direction of first one. Magnetic field produced around a straight conductor carrying current. Look here, this is the straight conductor. Assume that in which the current is flowing. Current is flowing. Observe. Then obviously the magnetic field is developed around this conductor. We have to state the rule to determine the direction of magnetic field produced around this conductor. Here, what will be the pattern of lines of force around a straight conductor carrying current? Yes, you are right. It is concentric circles. Then to know the direction of magnetic field, which rule should be used? Yes, you are right. It is Maxwell's right hand thumb rule or Maxwell's right hand grip rule. What it is? What is the statement of this? According to this rule, imagine a man holding a straight conductor carrying current in his right hand. If the thumb point indicates the direction of flow of current, then encircled fingers indicate the direction of magnetic field or magnetic field lines. Here, observe, current is flowing in the upward direction. Lines of force, it will be, the direction of lines of force will be in the anti-clockwise direction. If the current is flowing downward, it will be in the clockwise. Clear? First one is Maxwell's right hand rule. Then we have to write the statement. Second one, force experienced by a current carrying conductor placed in a magnetic field which is perpendicular to it. I hope that you are able to recall the experiment related to this. Force experienced by a current carrying straight conductor placed in the magnetic field. Just to recall this experiment, this is a horseshoe magnet and it is placed on the support, and we will go for placing a straight conductor in which current is flowing. It is to be placed in the magnetic field of horseshoe magnet. Got it? Then obviously it experiences the mechanical force. The reason is when the current flows through this conductor, the magnetic field is developed around it. As it is under the influence of the magnetic field of the horseshoe magnet, it experiences the mechanical force. The direction of mechanical force can be known by using which law? Yes, Fleming's left hand rule. According to Fleming's left hand rule, see that here, if you go for taking this as north and this as south, lines of force spread from north to south. Direction of current, it is inside the board. Then mechanical force, it is on right side. If the terminals are changed, then it gets reversed. Followed? Yes. What is that? Fleming's left hand rule. What is the statement of this? Yes. According to this rule, we have to arrange the first three fingers of our left hand mutually perpendicular to each other. If the forefinger indicates the direction of the magnetic field and the middle finger indicates the direction of the flow of current, then the thumb indicates the direction of mechanical force acting. Clear? Yes. Now move on to third one. See, current induced in a coil due to its rotation in a magnetic field. Current induced in a coil due to its rotation in a magnetic field. Observe, I am going to take a coil. Well, it may be circular or rectangle, whatever it is. See that. It is a coil. Current induced in a coil due to its rotation in a magnetic field. So it is kept in the magnetic field. When it is made to rotate, when this coil is made to rotate, it cuts the lines of force which is spread from north pole to south pole of the magnet. As the magnetic field linking with the coil changes, the current is induced in the coil. We have called this phenomenon as electromagnetic induction, right? Then to know the direction of current induced in this, which rule should be used? Yes, you are right. It is Fleming's right hand rule. According to this rule, look here. See, according to this rule, the forefinger indicates the direction of field lines. Then the thumb indicates the direction of motion of the coil. Then the middle finger indicates the direction of induced current. Here, current is induced in this direction. If the armature is made to rotate in the clockwise direction, then it cuts the lines of force. Obviously, the as the magnetic field changes, current is induced. So this is the direction of induced current. Followed? Yes. Once I tell the statement of Fleming's right hand rule, it states that arrange the first three fingers of right hand mutually perpendicular to each other. If the forefinger indicates the direction of magnetic field and thumb indicates the direction of motion of the coil, then the middle finger indicates the direction of induced current. And Fleming's right hand rule is also known as dynamo rule. You are very familiar with that. And left hand rule is also called motor rule. Followed? Hope that you are able to write the answer for both the questions. Just go for writing yourself. Then after that, you can check with my answers. Yes, start writing. Observe. Here I have written. You just check that with your answer. See, here the current is induced in the coil B. The reason, it has been given that when the current flows through the coil A, then magnetic field is developed around the coil A. And in the magnetic field of coil A, coil B is present. Next, when the current in the coil A is changed, the magnetic field linking with it also get changed. And the same magnetic field which is linking with the coil B also get changed. Hence, the current is induced in the coil B. I have less space, so that first you go for copying this, then I'll go for writing that. Yeah. Dear students, go for checking what you have written by observing this. See, first one, to find out the direction of the magnetic field produced around a straight conductor carrying current, we have to use Maxwell's right hand rule. The statement has been written. And in second case, to find out the direction of the mechanical force acting when the conductor carrying current is placed in the magnetic field, we have to use Fleming's left hand rule, which is also called motor rule. And to find out the direction of the induced current, then we have to use Fleming's right hand rule, which is also called dynamo rule. And another name is generator rule. The statement of all the three are given once you check that. Yes. Observe. It is 16th one. Go through the statement. Explain the underlying principle and working of an electric generator by drawing a level diagram. What is the function of brushes? Yes. Now, see, explain the underlying principle of working of an electric generator. First, let us go for writing the principle of electric generator. Dear students, electric generator is nothing but dynamo. Then what is dynamo? It is a device which converts mechanical energy into electrical energy. Definition has not been asked. Only for the sake of information, I have written. But we have to write the principle on which the dynamo works. We know that when the armature in the dynamo, when the armature is made to rotate, then the magnetic field linking with it changes. Due to this, current is induced? It is nothing but electromagnetic induction. So we can write that dynamo works on the principle of electromagnetic induction, EMI. So according to this, if you want to write the statement, you have to write like this. When the coil is made to rotate, which is placed between the poles of a magnet, then the magnetic field get changed. As a result, the current is induced in the coil. Another simple way of writing is, whenever the magnetic field linking with the coil changes, the current is induced in the coil. That should be written. Okay, you have to write the principle yourself. Next, diagram of electric generator. Look here, it's very simple. Here, these are the poles of a horseshoe magnet. Here, horseshoe magnet, we know that it is a strong magnet. Hence, it is called the field magnet. And this is north pole and is south pole. And we are going to take armature is nothing but a rectangular coil of insulated copper wire. This is, you may name this as A, B, C, D. Next, after that, here the free ends are connected to two full rings, two full copper rings. They are also called slip rings, SLIP, slip rings. You may name them as R1 and R2, which are in contact with two sliding brushes. They are carbon plates. You may call them as B1 and B2. Connect the carbon brushes with the help of the conducting wire to the terminals of a load. You may take the galvanometer as the load, because to check the current induced, we can go for using this device. Next, it's working. Look here. Once I tell you, leveling. N and S are the poles of field magnet. ABCD is a rectangular coil of insulated copper wire called armature. R1 and R2 are two copper rings. B1 and B2 are two carbon brushes. And G is galvanometer and W is wire. Then working. Here, I have already explained in the theory class. Once I go for telling that in brief, afterwards you have to write its working yourself only in some sentences. Look here. Here, and we will go for connecting it to the axle, because we have to make it to rotate. The reason is for inducing the electric current, the magnetic field linking with the coil should get changed. Hence it is rotated. Look here. When the armature is made to rotate in the clockwise direction, like this. When the armature is made to rotate in the clockwise direction, then it cuts the magnetic field lines. Then magnetic field changes. As a result of it, current is induced in the coil. And the direction of current, induced current, can be known by using Fleming's right hand rule. Look here. Here in right hand rule, forefinger is field, magnetic field, thumb is induced current, and the middle finger is induced current and thumb is motion of the coil. When the armature is made to rotate in the clockwise direction, then current is induced in the coil through A, B, C, D. After half rotation, D comes in contact with B1 and current in the external circuit flows from B1 to B2. Clear? Next, during next half rotation, current is induced in the coil through D, C, D, A, and A, it comes in contact with B2 and current in the external circuit flows from B1 to B2. You can observe that the direction of current, induced current, gets changed after every half rotation. First time it flows from B1 to B2, second time it flows from B2 to B1. That is why it is called alternating current dynamo. Hope that you have understood. Very simple way of writing. The working is, first point. When the armature ABCD is made to rotate in the clockwise direction, the magnetic field linking with it get changed. Second point, the current is induced in the coil through ABCD. Next point, D comes in contact with B1 and current in the external circuit flows from B1 to B2. Got it? Next, during next half rotation, I am telling 4 point. During next half rotation, current induced in the coil through DCDA. Next point, A comes in contact with B2. Current in the external circuit flows from B2 to B1. Here, the direction of current changes after every half rotation. That is why it is called AC dynamo. This is the working. Clear? Next, what is that? What is the function of brushes here? Very important. Look here. Whatever the current is induced in the coil, it flows to the external circuit through B1. So we can write the carbon brushes make the induced current or transfer the induced current from the armature to external circuit. Very simple. Once I tell you, carbon brushes. You know that carbon plates, it is good conductor of electricity. It allows the electric current to pass through it. Whatever the current is induced in the coil, that will flow to the external circuit through this carbon brushes. Followed? Yes. Again I tell that the working of carbon brushes is, it transfers, carbon brush transfers induced current from the armature to the external circuit. Okay. You only have to write first. Write the definition of dynamo. Next, principal EMI, and write the statement of that principal. Next, draw the diagram. Go for labeling the parts. Then after that, go for writing the working point wise, how I explained. At last, write the function of carbon brushes. Yes. Dear students, I hope that you have written already about this complete explanation. Now, go through this 17th one. When does an electric short circuit occur? Dear students, we are very familiar with short circuiting. Right? What it is? We know that when the live wire come in contact with the neutral wire directly, then what will be the resistance of the circuit? It almost becomes zero. Then large amount of current flows through the circuit. So due to this, even the spark may also come. This is what we say the short circuiting. But what are the possible ways which are responsible for short circuiting? Yes, this is one thing, when the live wire comes in contact with the neutral wire directly. And the second point is, if there is any damage in the wire, then also the large amount of electric current flows, which leads short circuiting. If there is damage in the electrical appliances also, if faulty appliances are used, again it draws the large amount of current. If there is no proper insulation on the wire, then also short circuit happens. Followed? Yes, please go for writing that. Yes, these are the different ways by which the electric short circuit happen. You just check with your answer. Now, go through 18th one. It is, what is the function of earth wire? Why it is necessary to earth metallic appliances? The students, we are very familiar with this earth wire, particularly in domestic wiring. That is, the wiring which is made inside the house is called domestic wiring. In that, we go for using 3 wires. They are, one is live wire, which is at 220 volt potential difference, then neutral wire at 0 potential difference, and another one is earth wire. It is also, its potential is equal to the potential of the ground, that is 0 volt, right? Then what is the function of this earth wire? We know that earth wire acts as a even safety measuring as well. The reason is, in the metallic body, whatever the electrical appliances will be there, metallic appliances will be there. When excess amount of electric current flows through them, there is a chance of short circuiting, and if they are connected to the earth wire, then this earth wire will transfer this excess amount of electric current from the metallic body to the ground, so that it protects the appliances from short circuit. Clear? That's the main function. Then why it is necessary to earth metallic appliances? I told you it is to avoid the short circuiting, and so that the appliances will be safe. Yes, please go for writing the answer yourself. Yes, dear students, again check your answer with this writing. Function of earth wire. Mainly, it transfers the leakage of electric current from any electrical appliances to the ground. Right? That is the main function. Why it is necessary? The same thing. We know that earth wire, it connects the metallic body of the appliances to the ground. Then, if there is leakage of current of the metallic body, then earth wire keeps the metallic body's potential difference to 0 volt, which is equal to the potential difference of the earth, and it transfers the current to the ground. This prevents any electric shock to the user. Hence, earthing is necessary. Followed? Yes. Even I have already explained you in detail about earthing. You can just recall that by observing the previous videos. Okay. So these are the questions that are given in exercise. With this, the chapter has been completed. Now, once we shall go for recalling all the points what we have discussed in this chapter. Dear students, here I have made some of the points what we have discussed, important points what we have discussed in this chapter. Just we shall go for recalling one after the other. The first point, it's important one, magnetic field. Just to recall the definition. Yes, when an electric current, the region around a magnet where the magnetic force is present and the magnetic effect is felt is called magnetic field. And we know that magnetic field is denoted by the symbol capital B. Over that we put arrow mark. Then what type of physical quantity it is? Yes, you are right. It is a vector quantity because it has both magnitude and direction. And this magnetic field can be measured with a unit called Tesla or Weber per meter square. Next, magnetic field lines. See, when you go for taking a magnet, around that the field will be there, magnetic field, but it is not visible. Therefore, this invisible field is to be represented with a set of lines, and these lines are called magnetic field lines. And this magnetic field lines, they have their own characteristics. If you want to recall some of them, the magnetic field lines never intersect each other. It's very important. Magnetic field lines do not intersect each other, and they are very strong enough such that they can penetrate or they can pass through the materials like the glass, wood, stone, bone, muscle, etc. Got it? Then magnetic lines of force usually they exist more at the poles than at the middle. The reason is the magnetic field strength is more at the poles. Followed? So these are, and conventionally the magnetic lines of force exist at North Pole and end at South Pole. Clear? These are four important points. One is the lines of force do not intersect each other. Second one is they can penetrate through the materials like glass, paper, bone, mud and stone, wood and all. Then third point is the lines of force exist maximum at the poles than at the middle. And fourth point is, conventionally the lines of force start from north pole and end at south pole. Then magnetic effect of electric current. This is the name of the chapter. Definition. We know, dear students, we know that whenever an electric current flows through the conductor, the magnetic field is developed around it, and this is known as magnetic effect of electric current. And who discovered it? It was discovered by Hans Christian Ørsted. Even we have come across the experiment conducted by Hans Christian Ørsted as well. Later we'll come to know, later we'll recall that one. Observe here. In the next part, we have learnt about pattern of lines of force around this bar magnet and different types of magnets. We know that the lines of force, pattern of lines of force will not be same around all the magnets. It will be differ, depends on the shape of the magnet. As the conductor carrying current acts as a magnet, so we can show the pattern as well. These are the some possibilities. The first one is a straight conductor carrying current. What will be the pattern? If the current is flowing in a straight conductor carrying current, then the lines of force around it, it will be concentric circles. Then another one is circular conductor carrying current. In case of circular conductor carrying current, the pattern of lines of force is concentric circles near the conductor. But at the middle of the coil, it will be straight and parallel. What do you call the magnetic lines of force which are straight and parallel? It is uniform magnetic field. Next, third one is a solenoid. We know that solenoid is a long coil of insulated copper wire having large number of turnings. When the current flows through that, then again it acts as a magnet. Then pattern of lines of force around a solenoid, it is straight and parallel inside the solenoid. Whereas outside the solenoid, it is similar to that around the bar magnet. This is the pattern. Then bar magnet, we have already learned that. Next, let us go for recalling some more important points under that. Some important experiments. The first one is Ørsted experiments and its conclusion. You just go for recalling is the experiment conducted by Ørsted. He is the scientist who has given information about magnetic effect of electric current. That means whenever an electric current flows through the conductor, magnetic field is developed around it. For that, he conducted the experiment in a very simple way. He made a simple circuit, then below the wire, he placed the magnetic compass, right? When the current flows through the wire, then the needle in the magnetic compass get deflected in one direction. So this deflection is due to the presence of the magnetic field around it. And where is that magnetic field? How is that produced? It is produced because of the electric current flowing through the conductor. When the current flows through the conductor, magnetic field is developed, and in that magnetic field, the compass will be there. Hence, the needle get deflected. And the direction of deflection of needle can be known by using a rule that is called Ampere's swimming rule. Right? Hope that you might have remembered that. Next. Conclusion, it's very simple. When the current flows through the conductor, magnetic field is produced around it. Another one is Faraday's experiment and its conclusion. Faraday, see that Ørsted here shown that when current flows through the conductor, magnetic field is developed, which is called magnetic effect of electric current, which means current can produce magnetic field. And whether the reverse effect of this is possible, this was the question raised by Michael Faraday, even answered by Faraday only. That means, is it possible for a magnetic field to produce the electric current? Yes. This was proved by Michael Faraday through his experiment. And he took a cylindrical cardboard, then he took a long copper wire and it was wound around the cylindrical cardboard, and the free ends were connected to the terminals of a terminals of a galvanometer to check whether the current is generated or not. Then he took the bar magnet, one of the pole of the bar magnet, it was inserted into the coil. Then he noticed that there was deflection in the galvanometer, which indicates the current is induced. Then he pulled out the bar magnet from the coil. Again there was deflection, but this time it was in the opposite direction. That indicates the direction of that indicates the current is induced. And third time he kept the bar magnet inside the coil at rest. So here the deflection was 0. That means no current is induced. So from his experiment, he concluded that in the first two cases only, current is induced. That is, when the bar magnet is inserted into the coil, when it is taken out from the coil. Why it is? It is because when the bar magnet is either pushed into the coil or pulled out from the coil, the magnetic field linking with the coil changes. So this change in magnetic field induces the current in the coil. And he called this as electromagnetic induction. Hence the credit of discovery of electromagnetic induction goes to Michael Faraday. And the current, whatever it is induced, is called induced current. And this induced current depends on some of the factors. They are, one is, see that if more amount of induced current has to be produced, then the magnetic field linking with the coil should get changed more also, right? But how it is to be done? One is, it depends on the speed of the magnet which is inserted into the coil. And second one is strength of the magnet as well. If the more strength is there, more amount of magnetic field will be present around it and more amount of field get changed. And third one is the number of turnings of the coil. As the number of turnings increases, then the lines of force are cut by maximum number of times. Therefore, more amount of current is induced. Clear? Yes. Next, the force on a current carrying conductor in a magnetic field. This is also very familiar to us. That is, whenever a conductor in which current is flowing is kept in the magnetic field, it experiences the mechanical force. You just recall that experiment. You had taken horseshoe magnet, then you'll go for, and it is to be placed on the support. Next you go for taking aluminum rod, and both the ends of the rods are connected to copper wire, and this rod is to be suspended freely inside the horseshoe magnet with the help of iron stand. Then the free ends of the copper wire are connected to terminals of a battery. When you close the circuit, immediately the current flows through the aluminum rod. Then magnetic field is developed around it. So this magnetic field will intersect with magnetic field of the horseshoe magnet. As a result, the aluminum rod experiences the mechanical force. So this direction of mechanical force can be known by using Fleming's left hand rule, right? And this is the principle, that is, a conductor carrying current kept in the magnetic field experiences the mechanical force. This is the principle on which the electric motor works. Please do remember that. Next, we have, with respect to all these, we have some rules. Look here, first thing, we have come to know that pattern of lines of force around a straight conductor carrying current, circular conductor carrying current, and solenoid. In all these cases, the magnetic field is present, and the direction of magnetic field can be known by using the rule that the first rule is Maxwell's right hand rule. What is the statement of this? Say, according to Maxwell's right hand rule, you have to imagine a man holding a straight conductor carrying current in his right hand. Then, if thumb point indicates the direction of the flow of current, then the encircled fingers indicate the direction of magnetic field lines. This is the statement. If the current flows in the upward direction, then the direction of field lines is anti-clockwise. If the current flows in the downward direction, then direction of field lines will be in the clockwise direction. Followed? Yes. Next, clock phase rule. We know that this is the rule used for identifying the pole of circular magnet. So that is, we have already learned the pattern of lines of force around a circular conductor carrying current. When the current flows through the circular conductor, then it acts as a magnet. It has two poles, north and south pole. See, you have to imagine that the face of the coil in which the current is flowing in the anti-clockwise direction, then that face acts as south, right? I'll draw that. Here, the face of the circular conductor in which the current is flowing, so this face acts as south pole. The face of the conductor, circular coil in which the current is flowing in the anti-clockwise direction, this face acts as north pole. So this is the clock phase rule. Next, another one, Fleming's left hand rule. It is also called motor rule. Earlier just we have come to know that that is, whenever the conductor carrying current is kept in the magnetic field, it experiences the mechanical force. The direction of mechanical force can be known by using Fleming's left hand rule. According to his rule, we have to stretch the first three fingers of the left hand mutually perpendicular to each other. Here, if the forefinger indicates the direction of the magnetic field and the middle finger indicates the direction of the flow of current, then the thumb indicates the direction of mechanical force acting. And this is also called motor rule. Remember. Next, another one, Fleming's right hand rule. So Fleming's right hand rule is used to know the direction of the induced current. So induced current was induced in the experiment done by Michael Faraday, right? So there, according to the Fleming's right hand rule, here also we have to stretch the first three fingers of our right hand mutually perpendicular to each other. If the forefinger indicates the direction of the magnetic field and the thumb indicates the direction of the motion of the coil or motion of the conductor, then the middle finger indicates the direction of the induced current. So this rule, Fleming's right hand rule, is also known as dynamo rule or generator rule. Next, dear students, in this chapter even we come across some of the important diagrams. Earlier we have already come to know that is the diagram with respect to the pattern of lines of force around. One is straight conductor carrying current, second one is circular conductor carrying current, third one is solenoid carrying current, then fourth one is Faraday's experiment. Next, apart from this, we have some more. The electric motor, it is also very important. It's a device which converts electrical energy into mechanical energy. Then electric generator, nothing but dynamo. It is a device which converts mechanical energy into electrical energy. And another one is common domestic circuit, is also very important. First, from the electric pole we go for taking the wires, that is, one is live wire and another one is neutral wire, and then they are to be taken to the meter box. Then after that, before that the fuse, then after that meter box, then main switch, then after that from there it will be connected to different electrical appliances, and the electrical appliances are to be connected in parallel, the reason is they can be used individually. Please learn these three diagrams, which are very important in the examination point of view. One is motor, second one is dynamo, and another one is domestic wiring or domestic circuit. Next, another one, conductor carrying current kept in the magnetic field experiences the mechanical force. That is also very important in the examination point of view. Then apart from this, in this chapter, we will also come across some of the differences between some factors. They are, look here first, regarding the differences between dynamo and motor. Very simple. In case of dynamo, it is a device which converts mechanical energy into electrical energy. Motor, it is a device which converts electrical energy into mechanical energy. Here the current is produced, here the current is used. Then like that, we have some more differences are there. You can just go for recalling all the points. Next, AC dynamo and DC motor, the same points are to be written. But another important information is, in case of AC dynamo, we go for using full rings, nothing but slip rings. But DC motor, we will go for using in DC motor, we will go for using the split rings. They are half rings. And in case of AC dynamo, we go for using either the bulb or else galvanometer as the load in the external circuit. Whereas in motor, we will go for using the battery in the external circuit. Here, in case of AC dynamo, the direction of current changes periodically after every half rotation. But here, in case of motor, DC motor, the direction of current will be same. Followed? Next. Observe. Electromagnet and permanent magnet. See that. Here electromagnet, it is obtained by placing the soft iron core in the solenoid carrying current. That is the electromagnet. And the permanent magnets, they are to be prepared by adding some of the impurities to the natural magnet. And here for permanent magnets, we can give whatever the shape we want. And the strength of permanent magnet is less than the electromagnet. But strength of electromagnet can be increased. Followed? Next. Observe. Alternating current and direct current, AC and DC. If the direction of current changes periodically, it is called alternating current. If the direction of current in the circuit is same, then it is called direct current. And the source of alternating current is the generator that we use in power plants, and the source of DC, that is direct current, is cell or battery. Next, let's concentrate on some more important points. In the last part of the chapter, we come across these terms: short circuiting, overloading and fuse. Short circuiting, just we have already come to know in today's period only. If there is damage in the damaged wire in the circuit, or if the live wire comes in contact with the neutral wire directly, then the resistance of the circuit almost becomes zero. Then extremely the large amount of current flows through the circuit. Due to this, it may produce the spark also, and this is known as short circuiting. Then another one is overloading. Dear students, we know that when the more number of electrical appliances or electrical items are used simultaneously, or when more number of plugs are used in one socket only, then it draws the large amount of electric current. Even it may affect the electrical appliances as well, and this is called overloading. That very simple. When the capacity of every socket is fixed. If it is if it draws the current to more than the limitation, then that is what we say overloading. Followed. Next one, fuse. Fuse, it is a safety device. We call it as a safety device which breaks the circuit automatically when excess amount of electric current flows, right? Then in fuse, we go for using an alloy of tin and lead. And what is its important characteristic? It has low melting point. When excess amount of electric current flows, then it gets that is alloy gets melted. Circuit is broken, so that it will save all the electrical appliances. And this is also called the traffic police. Then next, induced current. We have already come to know that. That is, when the magnetic field linking with the coil changes, then the current is generated. This current is known as induced current. Then, in case of domestic wiring, we go for using many terms. Among them, these are the different wires: live wire, neutral wire, and earth wire. Live wire, it is a high potential wire. Live wire is a high potential wire, and its potential is about 220 volts. And do remember, the fuse is always connected along with the live wire, because the main current is flowing in the live wire. And one more important point, in fuses also we get different ratings, and they are used for different purposes. If it is only for lighting, that is to run TV, fan and the electric bulbs and all, we go for using the low rating fuse which is of about 5 amps. And another for heating purposes, that is to use the electric geyser, electric oven and all. So then we go for using the fuse of rating 15 amps. Next, here live wire, it has a color code. Its color code is either red or yellow. And another one is neutral wire. Neutral wire, it is a low voltage wire. Its voltage is of about 0 volt. Hence the potential difference that we use in India is 220 volts, and its color code is, it is black or blue. Then earth wire. So this is the wire which is connected from the metallic body of the electrical appliance to the ground. Its main function is it transfers the leakage of electric current from metallic body of the electrical appliance directly to the ground, so that it will save the appliances. Then its color code is, it is green. Clear? And please do remember, green or yellow. But particularly for live wire, we go for using red color code or else brown color code. Next, dear students, in case of dynamo and motor, we go for using many items in that. They are, it may be the magnet, it may be the armature, commutator and all. Here we have mentioned them. Look here, armature, it is a rectangular coil of insulated copper wire, and then its what is its function? It will increase the capacity of the motor as well as dynamo. It will increase the capacity of the dynamo by rotating. It will increase the capacity or power of the motor again by rotating. Then commutator, if the armature, if the free ends of the armature is connected to split rings, then this is called the commutator. So this reverses the direction of the current in the armature. Followed? So, and this is also responsible for making the armature to rotate continuously. Next, couple formation. We know that in case of electric motor, whatever the rectangular coil will be there, when the current flows through that, then it cuts the magnetic field, then it experiences the mechanical force. This mechanical force acts on the opposite limbs. Once at one arm, if it acts downward, then under another arm it acts upward. So, but these two forces will be having equal magnitude. If two forces having equal magnitude act on the opposite limbs of the coil in the opposite direction, then the coil start rotating. This is called couple formation. Once I tell you that if two equal magnitude forces act on the coil on the opposite arms in the opposite direction, then the coil start rotating. This is known as couple formation. Next, carbon brushes. We know that the function of carbon brushes, they are nothing but carbon plates. They are the good conductors of electricity, but its function is different from dynamo and motor. In case of dynamo, their electric current is induced, that is generated, electric current is produced. So this electric current produced is to be transferred from armature to external circuit by this carbon brush. Once I tell you, it transfers induced current from armature to the external circuit in case of dynamo. In case of motor, it transfers the current from external circuit to the armature, and it will also help in reversing the direction of current in the armature. Next, it transfers. Then split ring, it will help in reversing the direction of current in the armature. Please do remember that one. And slip rings, these are the full rings that we use in AC dynamo. And dear students, you know that AC dynamo can be converted into DC dynamo just by replacing the full rings by split rings. Got it? So this is the important information. Dear students, this is about the revision of the chapter magnetic effect of electric current. So with this, the chapter has been completed thoroughly. Next, and the next work is yours. Dear students, even I have already distributed the notes as well. There also you will get the complete information about what information is there regarding magnetic effect of electric current in NCERT textbook, as well as some of the reference books like S. Chand, Dinesh, All-in-One and Golden. By referring all these, notes has been prepared. Please make use of it. Then in the notes, even we have answered for blue box questions as well as exercise questions. Yes, in the next class we can commence the new chapter. So with this, let us stop the class. Thank you very much.